Gurpir. Thanks, Santosh, for this. Let's just start, right? And before we go over and understand what resilience is and how do you plan for it and what stage, I wanted to cover certain principles which we'll be solving along with talking about resilience, right? One point which Santosh brought out, like scaling, right? Throughout the session, we'll talk about certain tenets which makes you decide on, okay, how do I scale? What are the kind of parameters I should look at in terms of scaling, right? As Gurpir was telling that there was a time when these scaling events was a very predictable event, that there will be some marketing campaigns which you will run, and the eventual side would be that it will be an increase in traffic. Now you don't even know that a viral tweet can actually increase your traffic by 10x, right? And any other event can actually increase your traffic. So how are you planned for that? And how do we navigate precisely on these principles and make sure that for any unpredictable events also we are covered? Second aspect which we will talk about is measurement. That we talk a lot about best practices or design patterns or architectures, right? That, like, for example, doing a multi-region object storage for better resilience. What does it mean, right? And what actually it helps you to in your application? And second, how do you measure it? That is it actually affecting or impacting your applications or not? Third, but one of the most principal components, especially in the macroeconomic conditions which we are going through, is cost efficiency. There are a lot of things which you can do to be more and more resilient, but as a startup or as a founder and the founding team, you should always have been asking these questions: what are good to haves and what are must haves, right? And how do you do must haves while ensuring that the cost is at check, right? Having 20x capacity being running 24/7 may give you the same kind of resiliency, but it will end up burning your money a lot faster than a more optimized similar resilient architecture. So those are the key things which we'll talk about along the way when we'll talk about resiliency. So first, let's start with how do we define resilience, right? And to define resilience, the first and the most important pillar is to define availability. In a very, very simple term, availability is basically the uptime your application has against the total time. So if I look at from monthly perspective, that if your application is running 24/7 without any availability issues, it's basically 100%, right? And if it's up all the time. The key aspect to understand, and that's what we also do at Google Cloud, is any planned downtime is still downtime. And you should consider that as a impact in availability, right? I have a lean business hours, that's why it takes 6 hours to upgrade my application. Could be a strategy, but you are still impacting availability. Those are certain things which you should understand, because as we were talking about, right? And suddenly you are now at a stage where you're scaling and you have multiple geo traffic, your maintenance would not be happening because you will be actually causing downtime and you have to devise a new strategy. That's why any planned downtime or unexpected downtime together should be considered as a availability failure. Moving to the architecture initially was simple, right? Everything, whenever you start today, also when you're building an MVP, it's basically one server which has everything, which has application database, backend, front end, and you're just serving it to make sure, in certain cases, fitment, in certain cases to ensure that you are running the systems and actually making your product more robust. But as and when systems grow, and especially because of the evolution in technology today, more and more systems are becoming distributed and complicated. So you have to understand the availability principles also accordingly, right? There are impacts when an application has a parallelization versus chaining. So for example, you have a front end and a database, and you have single instances of both. If front end goes down, there's no point of database being running, because your systems will not be able to interact, your end users will not be able to interact with that, right? At the same time, if you have two instances of the same machine running, where you have a mechanism where out of the box it can move the traffic from one server to another server, it gives you a parallelization mechanism. So then the availability gets add up, right? And then and that's why it's critical when you're designing system, understanding that what are all your single point of failures, what are your areas where you can actually introduce parallelization, and at the same time mitigate areas where chaining is like a must, right? Like you can't actually replace your front end system with a database or vice versa, right? So understand that how can you mitigate the impact of chaining, right? Is there a fallback? Is there a landing page where you can take information asynchronously and process, right? Those are some architecture decisions which you take initially when you're designing systems for failure. An important factor when we look at in terms of availability is also the indicators, that whenever it doesn't matter when this happens, but whenever you're going GA and you have end users using products, your products, you should define those indicators, right? And like a service level indicator varies for product to product and platform to platform, right? For example, for somebody like us, a compute engine's availability metric would be an indicator. Whereas for an e-commerce application, it would be that what is your average response time of a request, right? Let's say that is 150 milliseconds is what your SLI is. That you try and do more than 99% of your request above less than 150 milliseconds. So that indicator comes up with this objective that, okay, for 99% of my time, I would try and do less than 150 milliseconds. And then there comes an agreement that which can happen between B2B, or you can actually work with your customers as well to give coupons or other stuff if you breach that. So if you have an availability issue, there are processed agreements that the moment there are applications which are taking more than 150 milliseconds for less than 99% of the time, you're basically in breach, right? So this is, even though you are in a business which is for end user, you still establish that at a platform level, because this gives visibility top down to understand how the application is behaving at all times, right?
So just to add a quick point there, I think this is also a function, as Nitin pointed out, a function of the architecture choice. And the architectural choice is also a function of the business that you have, right? Essentially, whether you have a backend for front end kind of an architecture, or you have an orchestrator which is going to sort of chain requests to multiple microservices downstream and then be able to sort of get response, which could potentially induce latency and increase response times, right? So it's a function of the architecture that is being chosen, and the architecture is also a function of the business. So I hear a lot of these founders coming and asking, hey, for a fintech product, is this going to be vastly different? Because they're sort of using the founder's lens to look at it. Or for a B2B SaaS versus a consumer tech product, is this going to be vastly different? But I think it all boils down to what I think Nitin started the conversation with, which was you'll have to measure what it looks like for you in production and what requests that you foresee, which is what Gurpir also spoke about. Some kind of forecasting in terms of what your requests, what your customer base, what your spiky traffic is going to look like. And that sort of back pressures your decision in terms of what architecture to choose, and hence these numbers. So yeah, that's the overall founder journey when it comes to sort of deciding on the architecture, etc. Over to you, Nitin. I just wanted to add a point that we have sort of faced from our founders frequently.
Thanks, Santosh, for that. So another term which is widely used is the high availability and disaster recovery, right? And they've been used almost all the time together, but there is we really need to understand that these are two different terms, right? And both are solving a different problem. So high availability in general is solving a problem of mean time between failures. So there is a failure, how soon you can recover from that failure and start serving the customers again, right? Ideally, all architecture choices should be focusing on decreasing that time. Lesser the time, seamless the experience is, right? Disaster recovery is an event where whatever the choices were or whatever the alternative, there is still a failure, right? And if a failure has occurred, how soon you can actually come back, right? The mean time to resolution. Then basically, if the data center where you're hosted on, or a cloud provider region or a zone you're hosted on has an outage, how much time it takes for you to come back, right? That is an important aspect of designing the systems, because one principal component, if you keep on thinking about, I have covered all the bases and I would never see a failure, it it is a failure, because anything, whatever you're running on may fail, right? And you can't control all the paths. So the only catch-all situation for you is basically plan it in a way that if failure occurs, how soon you resolve it, right? Uh, and that's why availability can actually be looked upon another thing, right? That mean time between failure and the overall failure time plus resolution time. That addition also can be actually considered as your availability metric when you're designing, right? So these are the two lenses. If from a business lens, if I look at, uptime divided by total time makes total sense. But when you're designing and architecting systems, as a system engineer or a system architect, these are two things which you should look at, right? How resilient your systems are in terms of high availability, and what happens when actually a DR or a disaster has invoked. This, I was talking about, that HA is not equal to DR. When you create these systems, you should understand. So I'll try and explain it with an example, right? Let's say you have a database which has a primary copy and a secondary copy, and whenever there is an issue in primary, or be it a network issue or a database issue, it gets failed over, right? It's still, this gives you a high availability because you're ensuring that mean time to failures are less. But let's say a record gets deleted from your primary copy, or there is an alteration which has happened due to a human error or otherwise. What happens is that data is still lost. And that activity you cannot recover unless you have a recovery in place, right? It could be a snapshotting, it could be a standby on a different region which is not being used, and there could be multiple ways of doing that. So that is very important to understand. And second important factor is, you can have all these technologies, but if you're not testing it regularly, you would get failures when the actual event happens, right? So having a DR is not enough, right? You should always have drills, you should always have mechanisms to test it and seamlessly fail back. Another important area of consideration when you're designing these resilient system is, how do you fail back? Because in certain cases, what happens is, let's say a database goes down, you move over to your secondary, and you don't have a seamless mechanism to come back. There is no way of rewriting records back, or there is no way of actually ingesting my backlog data, which was there now in secondary. Those are some key principal components which you also have to understand and design. And that happens when you test your DR, right? At Google Cloud, when we do our DR drills, we actually inject failures, that from DNS layer to right at L4 layer of communications between databases or networks, right? And see how seamlessly we recover. So that, and in terms of when do you start it, even with a smaller system, you can actually create a replica and do such tests, right? Because if you start early, it is easier for you to manage when you scale. And the other way around becomes very difficult, right? And then it requires a lot of other interventions to fix it. So now we should be moving to actual design for resilience, but maybe break for questions for a couple of minutes.
Please free to add your questions on chat and we'll pick those up.
I think we can continue if.
Yeah, if no questions, we can actually continue. Now let's look at in terms of resilient design patterns. Right? When you are designing a resilient system, what are certain key things you can think about or manage, especially also from a perspective that now cloud is a prevalent choice of platform for people, right? There was time when you were deploying this on physical hardware or a colo provider, which has their own challenges, right? Isolation was a challenge, doing redundancy was challenge. There was no managed service as well, right? So the only thing what you get is compute, and then you develop, deploy everything on top of it. So which had significant amount of challenges in terms of managing. Those have eased down, but still in terms of design pattern, what you are looking at, you should consider what the capabilities you have and design your application around that. So the first thing is geo redundancy. Now it is becoming increasingly more important that almost everything what you're building can go global at any point of time and also have users from various geographic locations. So latency is one aspect of it. Also, recovering from failure makes it easy because usually cloud is an isolation construct from a zonal and a regional level. So on a disaster, on a natural disaster level, if something happens at a region, you still at a multi-region deployment setup, recovering for you becomes really easy. Another area which hyperscalers have invested heavily on is managed services, which actually comes natively with certain key capabilities like high availability based on certain SLOs, right? Kind of managed replication, kind of managed multi-region deployments. The scalability is out of the box, right? So, and being a startup, I think having a lean team is also a very important principle when you're building fresh, right? So leveraging onto managed services becomes an easy hook for you to be resilient at the same time, not overshooting your people and ops budget, right? High availability is a design choice which you should have, and we've been talking about that a while back as well, that even though you're at a very nascent stage, you're only catering to a handful number of users, you still should have mechanisms where in case of failure, you recover back fast, right? Data recovery can still be take a second place, and then we can design DR systems later. But high availability is not a area which you should ignore even when you're starting fresh, right? And especially with cloud in picture, those creating those solutions have become really easy, right? So it is not as complicated that you would need a lot of system engineers to design that today. Then automation. A very important and aspect of the entire infrastructure management or application management is that there will be human involved, and there are chances of actually those errors, right? Somebody debugging directly logging into the machine changed a certain setting which alters your application behavior, right? It is a reality, and it happens a lot. You try and avoid it, but you can't restrict it. So one good lever for that is use your infrastructure as coding tools to program your infrastructure, and which gives you capabilities like controlling drift, right? So even if somebody is troubleshooting and solving a problem in your system, once they are done, the system takes care of moving back to the same state as they were, right? And you're not depending on somebody to remember those changes. Similarly, if you adopt it early, it becomes easier. Otherwise, you may have heard a lot, right? There are tribal knowledge on the system that this particular system can be solved by this person, or this is a log file or a run book which we have to follow to in order to fix this. All that can be avoided if you are actually implementing these infrastructure as a code tools along with certain configuration guardrails, right? Even though a lean team, there could still be responsibilities that, okay, this is how the release pipeline works, or this is how you actually deploy certain things into production, right? And that can be scaled as and when more people join, and as and when you scale as a system on multiple microservices from monolith and stuff like that. But setting up these principles early actually helps, right? And automation is a key in terms of achieving those design patterns. Now, what we look at is we look at on each things, and also from Google Cloud's lens, that how do we offer certain things for you to start early. So the first thing is geographical redundancy, right? Fundamentally, the cloud is actually divided into 4 constructs. It starts from a zonal concept. Like when you deploy a machine, you deploy it in a zone. If that zone goes out, the machine actually is not performing for you, right? Then comes a regional construct. So if we have divided into multiple regions where there is a region which has certain things like a regional managed instance group, which can actually have machines across zones. So if one zone goes down, that regional MIG or a regional Kubernetes cluster is still functioning and effective. So your application doesn't take impact. Similarly with our object storage databases and our data analytics platform. Then comes multi-region. In certain solutions, what we have, typically with our OLAP solutions and our object storage, we give you a capability to design out of the box multi-region capability. This helps you to avoid creating additional DR or creating additional capabilities of DR. Another advantage this gives you is, like, for example, cloud storage. because it's multi-region, if you actually enable this multi-region as a concept, you can actually, what you can do is you can put your backups into a cloud storage and it automatically moves on to another region. So what happens is at a passive layer, your applications and databases becomes a multi-region construct out of the box. Right? Then comes the global deployments. That means that particular service or a feature is a global construct, and you do not have to worry about, okay, which region I am deploying it to and how is it going, or if it goes down, what happens, right? Pops up, all our firewalls, load balancer, our VPC, all are a global construct. So when, for example, a simple example that when you're deploying a system, you started early, you created a VPC, it right now functioning only for India as a region. Suddenly you expanded into EMEA and US. You don't have to do all that over again. The VPC is the same. You just expand it over top and just add on machines from different regions onto the same VPC, right? Those are some design choices which we have given to our customers so that they actually scale efficiently and be resilient at the same time.
Just another thought. What I wanted to add was all of, I think what Nitin said gets vastly complicated. As in when you have more than, let's say, one cloud or maybe cloud and a data center kind of a model, which is sort of hybrid, which also means that essentially you will get into that global kind of a bucket for anything which is even localized, but more than one cloud. So if it's more than one cloud, I think as Nitin pointed out, as you would want to keep it close to your colo or close to one region or one data center, you might have to ensure that all your cloud providers or let's say your data center is closest to the cloud provider's region, right? That sort of otherwise induces a lot of latency and then cross-cloud communication becomes a hassle. So that's another thing that we've been seeing, which is quite prevalent in the ecosystem, where you have more than one cloud and you sort of struggle to manage it. You've induced a lot of complexity to your architecture, cloud, cross-cloud communication, latency, everything takes a hit. In fact, all the metrics that Nitin pointed out earlier in the slide also has a function of multi-cloud now. So whatever he did will have to be multiplied by 2 or divided by 2 if you have 2 cloud providers instead of 1. So yeah, that's another point that we've been seeing in the ecosystem. So thought I'll add that. So over to you, Nitin.
Yeah, great point. And just to add on top of it, right, what happens is when you're doing multi-cloud, there are still now levers which actually helps you streamline some of that ops, but latency and in terms of understanding multiple technology will always remain an overhead, right? So we have to look at a fine balance between what exactly you need and how can you minimize in terms of operation overheads, right? With technologies like Kubernetes or technologies like Terraform, it gives you some kind of abstraction over cloud providers to actually minimize the overhead, right? In terms of at least the ops overhead. So because that is an area that becomes like the toil increases rapidly as and when you add more clouds to the picture. With this, now let's look at the common DR patterns, right? We've been speaking about HA and then that how you can induct to the system. Then after a point, once you are a business where you have sizable set of users, there is, and there are data being churned by these users, right? Where they are expected to actually, if they want the data back, you have to report it back to them, right? For example, the transaction details or the order IDs and things like that. Then your data becomes valuable. So then planning for DR becomes a must. Then also, like how we followed our HA journey, that it could be passive to active. Similarly, your DR patterns could be divided into multiple phases, right? You can start with a cold DR, move towards warm DR, finally a hot DR or a pervasive HA, which is basically a multi-region, multi-zonal construct where everything is seamless and you're not worrying about which region or which zone goes down. There are two important lenses which you look at this architecture patterns and decide which one I want to do and when I want to do. The first one is that the state of business you are in, right? You're starting low. The only thing what you're concerned about is no data loss. Cold DR becomes your job. choice. And then gradually, as and when your business scales, you understand and move over to other things. Another interesting lens is that what's the nature of the application? You're a very big business or a big digital native right now, but you have a back office processing job which runs every 6 hours. And fundamentally, the nature of the application is that 5 hours of loss that application can stay, right? And all this data which it processes ultimately goes to a downstream system which is already resilient. You don't have to design a very active or pervasive DR for that particular application, right? So these are the two important considerations for every application component when you're designing DR patterns. That what is the nature of the application and the kind of the failure withstand it can do from business perspective. Second, the nature of your application or nature of your business and what is the kind of customer expectations you have. Now let's look at example by example. How do you achieve that, right? The first one is when we've started new monolithic application is on a single VM. You have databases there, you have front end, back end, everything there, right? And it's a one zone application. So anytime that zone goes down, your application actually goes down. A simple way of doing that is just by taking snapshots and because snapshot is a global construct, what happens is you're still taking a periodic source of your data, whatever you are transacting, right? Anytime the zone goes down, you already have a load balancer. The only thing what you do is with that snapshot, you create another VM in a different zone and start live and start serving traffic. It reduces the failure time, but there is a data loss component attached to it, right? So if let's say your snapshot frequency is 1 hour, 59 minutes is effectively chances are there that your data can be lost, right? And that is something which you should be okay with, and you should have mechanisms that you can ask the customer to reprocess and other stuff like that, right? That is the first and the most least expensive way of doing DRs. The second one is like a zone DR with regional replication. This can act as a warm DR and a hot DR in a similar architecture. So you don't have to make a lot of changes. It's only that based on the business and the product type, you decide how you are doing, right? You can have a managed service or a compute-based database. There is a replication which is going on. It could be a read replica, it could be a standby instance. Then what happens in this architecture is at given point of time, there are two database services or two databases which are recording all your transactions. If there is a failover and there is a LB attached, it seamlessly moved to the secondary database. So the failure rate is very, very minimal. And if you look at this replication, depending on your data side, there might be a lag in seconds. So that's the only data loss you have, right? You can expand the exact same thing with an offline regional standby instance as well. So everything what you did is in Mumbai. Let's say you create a standby instance in Delhi, which is not serving live traffic, but still is recording all these transactions. So what happens is when that region goes down, you can still actually come back up in minutes. And again, depending on the application lag, that's the only data loss you are having.
Nitin, a quick question on that one. That I believe some of them might be having this question as well, which is around consistency, right? When you have multiple databases, there's always this question of how do I use which one, which is A versus B, so that there's consistency. What's your take on that, Nitin?
See, so there are right now with database tech also progressing, there are multiple ways to do it, right? So the most basic way is that when you're doing it and you want this to act as not only DR but HA, right? The question which you had. The first thing is separate those endpoints, make it a read replica endpoint and a write endpoint, so that at any given point of time, you're not changing it. The only change in that DR scenario would be that your read and write replica becomes the same endpoint. Right? And you still actually serve the traffic out of it. So that's the way. But if you're not using that as a DR, then what happens is there's only one endpoint which is acting as both. So if you're cost sensitive and you know that, okay, at this point, we don't want to spend too much, make it a HADR solution for your database, right? With two endpoints.
Got it. Fair point. Yeah.
Right. Moving to a regional and a zonal DR, right? Again, what we are trying to do is it could be a cold regional DR and a hot zonal DR. This like, it's like the moment your product fitment is done, market fitment is done, and you're at a stage where you're actually serving customers, this is something which is really easy to achieve, and it's cost friendly, right? Because what happens is, within a region, you have a couple of VMs which are deployed across zones. You have a internal routing policy which is routing both your DB primary and secondary. It could be a read replica, or it could be a standby, as we were just discussing. And then this kind of environment gives you out of the box capability of a zonal failure. At any point your zone goes down, you hardly see any interruption for your end user, right? At the same time, you can create a standby replica here, which is not being used, a very small size replica. Their only purpose is that it will send snapshots over to a different region or a multi-region bucket, right? Then what happens is, whenever you have a region failure, you can actually fail over to that standby instance and start serving traffic. This way, you are covered for most of the zonal failures, but region failure also is only increasing your RPO, right, and not RTO. Then finally, this is something like at a scale when you understand, like for example, in an application where you're doing payment processing, you know that goes down, it directly impacts business. Or you are doing an order management, something like that, which impacts revenue. Do a regional with our global load balancer along with a multi-region cloud SQL. All of these green lines which you're seeing in this, right? It's an active managed failure. So at any point of time, the zone goes down, the region goes down, the traffic automatically gets routed to your via global load balancer to the next region, right? The only, if you see, there are certain flows like your backend to backup is the only flow where there is a standby kickoff, right? That means it will take some time to recover. Otherwise, this kind of an architecture gives you HA, gives you DR, helps you with zonal failure as well as regional failure. The moment the application is critical and you have like a fintech organization is processing payments, right, where they have to report transactions. So any transaction lost is an opportunity lost. Also, it could be certain financial implications as well, right? So those kind of architectures should be evolving towards that. Another area which we started our conversation with is that what is the price in terms of getting this, right? For example, let's say you have an unpredictable load which is not scaling. It can withstand a zonal, it cannot withstand a zonal failure. Also, it is not auto scaling. So whenever the traffic spikes, there is a slowness in the website or the platform. All that, let's say, results in 5 less orders in a day, right? That is a dollar impact. Just by spending those, creating a multi-zone architecture, if you're an auto scaling, if you're able to withstand that unpredictable traffic and start generating more transactions, that is a ROI for you in terms of creating a system, right? So resilience doesn't always have to be your safety net. You can also impact your application performance and start generating more businesses, right? And that's why those measurements becomes really important. That once you have those parameters with you, you can always relate it to back to your business data as well. Now, when we're talking about various design various architecture patterns and everything, right? Fundamentally, if you're starting at any point of time, these 4 are core pillars which you should always look at, right? Which is compute, database, storage, and network. These 4 pillars, if you are solving resilience for them, irrespective of the kind of architecture choice like monolith or microservice, irrespective of your database type, NoSQL or SQL, you would be covered in terms of your resilience, or you would be covered in terms of your application behavior, right? So try and find out capabilities or try and latch on to capabilities like live migration. If the cloud provider is doing a maintenance, is it an impact on your application or a system? How can you avoid that, right? Is the service, if you're adopting a managed service for a database, which is like a most common behavior, is the service have built-in high availability option? Or I would have to design on top of it, right? Because if you're using a managed service, it should solve certain ops overhead, right? It should not increase, right? What kind of monitoring mechanisms I have for these core things, right? Then if you're looking at storage, because be it a cold DR or be it a hot DR, object storage becomes a key component in terms of ensuring that there is no data loss, right? Is that solution itself geo-redundant? Can it give you a low latency access? Because what happens is over a period of time, you've been storing these snapshots across, right, for multiple applications. Then cost efficiency was what we were talking about. It becomes a cost overhead for you to just store the backups, right? And then you decide, okay, this one I don't want, and in certain times you want to replay that. Those becomes challenging, right? So is there a storage offering as a managed service which can provide a low latency access irrespective of a non-durable storage type, like a cold storage or archival, right? Then in terms of network, another thing what we need to understand is latency and fault tolerance. What are the underlying networking capabilities the cloud provider is providing, right? One point which Santosh brought up, that multi-cloud is a reality. What are the connectivity options for these clouds? The moment I use multi-cloud, does this mean that all my communication is going over the internet, or there are capabilities, right? And if there are capabilities, what kind of fault tolerance capability they have, right? It should not be that you're opting for a private connection and that connection is creating a bottleneck for your application to be resilient or scale, right? Again, look at what are the kind of networking capabilities you have. So like, can my cloud provider offload the traffic as late as possible so that all my blast radius are covered and it is something which is under cloud provider's responsibility and not ours, right? So those are certain choices which you make for these core platform pillars when you're designing the systems. This is last but not the least. Look at everything what we have planned for, right, is covering HA, DR, but there could still be like a human error. Somebody deleted the database, or there could be unforeseen things that you had a region and both the regions got failed because of some reason, right? What are your backup options for any of the services, right? Be it compute, be it storage, network, or analytics. What are your backup options? Always try and have a backup as your last resort, so that worst case, if something, I've seen customers having in other cloud providers a ransom attack, right? And they don't have a backup. They never get that data back. It's a very anti-user experience behavior for it, right? So what are the mechanisms? How can you leverage them to have a safety copy all the times, right? Right, and I want to talk about a customer repo. We work with them. Those were the principal components which they had. Resilience was one of their most important challenges. Every time they were hitting a peak traffic which was unpredictable, they were facing slowness. So we worked with them. The latency was cut across from 500 milliseconds to 200 milliseconds. Anytime they were adopting or digitizing new customer or new platform, for 100% of the time they had peak traffic, they didn't face availability issue, right? So that is something which we work with them, and like between our team, that's the intent, right? To work with and create resilient systems as possible. So yeah, I think this was it from our side. Open to questions.
While that gets done, the question I had, Nitin, was I think based on the architecture, we as developers, as engineering leaders, we have always been doing this profiling so as to be able to understand the fan out density and the fan in density based on what your stack looks like, right? For instance, if it's Razorpay, there's going to be a fair amount of a fan in density for them. For a Google, for instance, where there is a lot of sort of ad traffic involved, there is a lot of fan out to ad partners and stuff. How much of that sort of influences resilience? Because that is also a metric that we would want to do, essentially in line with the observability and measurement that you said. Maybe also fan in and fan out metrics and their P99s and 98s could be calculated, because sometimes it could be that the Razorpay underperformed or Google contacted an ad partner and that ad partner underperformed. So, your numbers look hazy, at least ephemerally.
Very important point and a question, right? Because in today's time, it's not like you design a system and you are the only one interacting with it. There are a lot of people interact with your systems. The first one is still easier because what you do is you understand what your capacity is. When you're measuring, you load test it and design that, okay, this is my predictable scale limit as well, right? Even I can go to 10x, but not 100x, right? Which is fair also in all. So then you start mechanisms like decoupling, right? And how do you actually then create a filter on top so that any fan in, you know what is your request rate at peak. It may not be happening all the time, but whenever it is happening, that is your peak. Fan out is slightly tricky because it's not that you can do much about it, right? The only thing what happens is like putting better backoffs, right? Putting mechanisms like reprocessing and still giving a graceful response back to your upstream applications are certain mechanisms with which we have seen and we've worked with customers where they've seen successes. But fan out is usually a tricky one. So we also like do a lot of backups and a lot of reprocessing as and when required.
Got it. I think that's when I think the implementation of some kind of a circuit breaker at your end to ensure your numbers don't tank, and you calculate that formula that you just presented earlier in the slide. That value is sort of sacrosanct and sort of is in line with your performance and not the degraded performance of your partner.
Right. A couple of points up could be a circuit breaker limit, basically, so that you still have some buffer to withstand failures, right?
Absolutely. Shubham, do we have any questions that you want to read out?
Yes, we've got one from Tarun. He says, in your experience, what role has regional latency played when it comes to HA?
So, then good question. So, what we have seen, right? It has a lot of factors, right? When you're talking about databases, type of provider, type of networking, right? But there are certain places. So one thing is like when you're doing regional in terms of HA, synchronous is not something which you should go for, right? That definitely impacts the application performance because whatever it is, the kind of network, you still have a hop to go through and go over those wires and come back, right? However, with the current technology and the capabilities, async replication over a region for a DR is viable and it achieves significant scale, which we can definitely actually go for. Also understand like in terms of what's the nature of the application, right? Do it really needs like a synchronous HA over region or is it for DR, right? Like it could be certain cases that you have users from EMEA and India and you have 80% of your read load. That's why you want to distribute it. Makes total sense, right? Then you should go for it. But if the reason density is 90-10, then that is an overkill, right? So those are certain caveats also which lets you make these design choices.
So another question I had, Nitin, was around the data lakes and the data itself that we store, right? Sometimes how vastly it could be different for a serving stack versus the data that we store, because essentially the engineering sense is to sort of bring all the data worldwide to sort of one golden colo of sorts, which you think is the best, so that you can do a lot of, Spark jobs or Flink or any other data processing CDC on top to derive analytics, etc. What's your take? I mean, I've seen that being vastly different. What's your take been like, especially with Google's sense of...
Fortunately or unfortunately, that is a stack where every hyperscaler is very opinionated, right? So everybody has their own way of doing things, and everybody thinks that, okay, that's the way of doing. And that's why, see, for us, Google fundamentally is an open cloud, right? And that's why you see that our data stack also offers you capabilities like certain open source integration with our columnar storage, right? It's not just that you can type only SQL queries or store that kind of data, but having a central repository is something which is recommended, because what is happening today is that the kind of data-driven decision or the kind of impact a data can make to your systems and applications and also to business is immense, right? So losing out on data or putting it in multiple places where every stitching of a report or a new use case becomes challenging is an anti-pattern. So you still have to do it, if multi-cloud is such an important factor for that business, my suggestion would be pick an open source type which is compatible across hyperscalers and start storing data there, right? And then have a warehouse like that, and then run the jobs on top of it. And only the transformed data which you need for immediate basis could be on that hyperscalers data platform. That's kind of a like a coverage all kind of a scenario.
The other forward-looking decision is, which is probably not related to resilience, but now with Gen AI and AI being sort of the core, everybody's core tech, everybody's looking at, all the models will have to work on some data, right? So data will power all your AI modeling and the use cases that you implement. So having that, in case of Google Cloud, at least if everything is in BQ, we have a native integration with Vertex, which is our end-to-end AI platform now. So that sort of helps rather than the cost and the effort of creating pipelines and moving data around.
Got it. It makes sense. I think my experience has also been that, especially, just to add to whatever you said, there is also this problem of keeping your data in multiple sources and trying to do analytics where you would have multiple sources of truth, holes in data which are not catered to. Some data needs to be backfilled, which you will know only when it sort of arrives in one place. So I think I'm aligned with the fact that I think it makes more hygiene sense to sort of bring it all in one place so that golden data center / your colo provides or powers your analytics and reporting. Totally with you there. Makes sense.
No, thanks everyone for joining, and we look forward to more sessions in the near future.
Thanks everybody.
So thank you so much everyone for joining in. The intention here was to give you up close and personal sort of a purview with the experts, and that's the overall objective of techSessions by Elevation. We'll be sending you all an email which will have two things that I quickly wanted to shed light on before we wrap up. Number one is going to be a feedback form. We would love to have you give us feedback about this session, share your thoughts, and we'll definitely be incorporating those for our future sessions that we'll have as part of the techSession series. The second thing being details about the next session along with the registration link. Just the way we had the first session today, we plan to do another one on the 3rd of August in partnership with Mandiant and Google. Just to give you a quick brief, it's going to be about transforming security operations and incident response. And just to dive a little bit into that, compromise of the private industry for financial gain is a huge threat right now. And the objective of this session is to help you understand these threat actors and their potential attack vectors, detect, investigate, and respond to threats faster. Build on a secure by design, secure by default cloud platform, and of course extend your team with the expertise you need before, during, and after a security incident, and just so much more. So we'll be sharing those details with you along with the link in this feedback form. So request you to please go through both. Join us again on 3rd if you think that's relevant for you. Share it with other friends as well. So yeah, thanks a lot, and we hope to see you next time. And thank you.